So I don't know a whole lot about Go, but it's a language I've been meaning to learn for a long time. One thing that I do know about it is that it compiles to a single executable, and I'm pretty sure that single executable is statically linked, which makes it really convenient for just copying around to different machines of the same operating system and architecture, and being able to use it without having to install anything or go through a lengthy uh, install process. So this seems like it would be really convenient for actually a project that I've been meaning to do for a long time. So I've actually been building a bunch of web applications, and I use GitLab CI with their CI/CD pipeline, and I've built my own uh, tool essentially to do the deployment piece. So let's jump over to my CI configuration. So in GitLab, I have one stage which is deploy, in this case to production, um, and I set up an SSH client and then basically call this script, whiskeylocal.sh. Now, whiskey is the name that I've given to this tool, and I'll probably keep that name. But right now, whiskey is divided into a local and a remote piece, and they're just shell scripts. That was the easiest way to do it, just for now. But what I'd really like to do is have one executable that I can run both in my CI agent and on the actual deployment target. The goal of these scripts was that I didn't want to have any actual agent software or anything specifically running on the deployment target. So in this case, basically what I end up doing, you can see here, is I copy whiskeyremote.sh, the artifacts, and in this new version I'll add a config file. I copy those files over to the deployment target, and then I run whiskey remote with some configuration. So here we have some configuration variables that I want to actually pull out into a YAML config file. Similarly here, I have some configuration, but the meat of it that I really want to have configurable and separate from the tool that actually does the deployment is some of the things that are specific to the project that I'm deploying. So in this case, things like the name of the artifacts file, how to kill an old version and start a new version, any additional maintenance that needs to be done. In this case, I'm installing a cron tab file. Some projects, like maybe a node project, you might have a build step where you might want to do npm install or something like that. In this case, this is a .NET Core project. Everything's built as part of the CI pipeline, packaged up into a tarball, and then that gets deployed to the deployment target. So a couple things that I want to change here. One I've already mentioned is I want it to be one executable, and ideally I'd want it to detect if it's running locally and remotely, maybe something like check if the parent process is SSH. If I have to pass a flag like -- remote, I'm totally fine with that. I'd make the default behavior to assume that it was running on the local side. I do want to pull all of this stuff out into a config file. So I'm going to use YAML just to be consistent with things like GitLab CI, Travis CI, those sorts of things. YAML seems to be the going format for CI configurations these days. And I might add one or two other features as I get into it and as I see what Go's capabilities are. So I wanted to show you what my dev environment is going to be for this project. This is my Windows machine. Before this morning, I'd never installed Go here. So I actually did go through the entire setup process. I'm going to use Windows subsystem for Linux. That's where all the Go stuff is going to exist. One reason I'm going to do that is because I want this executable to run mostly on Linux. So my entire CI pipeline runs on Linux. The machines I'm deploying this stuff to,
They are also all Linux, so I think Windows Subsystem for Linux will give me the most flexibility there, and when I build it, I can just copy it around where I need to, and then worry about any sort of CI pipeline for this particular project maybe at a later date. So here's my Windows Subsystem for Linux prompt, and you can see I created a working directory in my home directory. This is actually linked to the working directory on the Linux side, so there's actually a symlink between the two so that I have one common working directory. I created a folder called Whiskey where all of my Go stuff is going to exist, and if I ls that, you can see I've created just a simple Hello World Go program. So I'll start up Visual Studio Code. You'll notice this loads on the Windows side, but it's connected to the Windows Subsystem for Linux file system by this remote WSL connection here. There's a bunch of information on how to set this up. I'll link one video in the description below. Scott Hanselman is a big evangelist for using Windows Subsystem for Linux for this sort of development, so I'll leave links to his channel and to one or two videos in particular, as well as the setup guide that I used to set up Go. And you can see it knows Go syntax highlighting. There's actually a linter that installed, and I can actually run it through the standard run menu, but I can also go run hello.go, and you can see it builds, runs, prints out hello world, so we know our dev environment is set up.
All right, so it's now Friday. I started this project back on Saturday, so 6 days ago. It didn't take me the whole 6 days to implement this, but that's just how time worked out when I had the time to actually write the code. I did run into some challenges, which I'll go through in just a minute. But first, let me give you a brief tour of the code that I wrote. So if we jump over here to Visual Studio Code, you can see my main basically just prints out a quick message just to indicate that it's running. This is helpful for CI pipelines. And I did make the logging, or the printing to the console pretty verbose for that logging functionality. Maybe in a future feature I'll give it a quiet mode and maybe improve some of the logging. That's one of the things that I kind of just I threw together as I needed it. If I needed to print something out, I did, and it probably could use a little cleanup here and there. So basically what we do is start the program, determine if we're running remote or locally, and determine the validity of the command line. If we're good, we determine if that remote flag is there, should run remote. All that does is just, it is the first argument -- remote. This is not very sophisticated, and eventually I'll probably want to replace this with a true command line parser. But for now, this was sufficient. If we're on the remote side, we run remote. Otherwise, we run local. Nothing too fancy there. Let's actually start with the local side because it's a little easier to think about, to reason through. So print out that we're running the local tasks, again, for debugging. We get the config, which I'll point out in a minute. For each target, so I did add the functionality to specify multiple deploy targets. So if you're deploying to a farm, you could specify, all 5 servers or however many you have in your farm, and Whiskey would just go through each one in turn, update it, and then there's some other features that could be built on top of that in the future, but I won't mention them quite yet. So deploying to target, we try to connect with an SSH connection, and create our temporary directory. So for the most part, I tried to make sure there was a one-to-one correlation with the code that I wrote in Go and the original shell commands that I created. at least for this first run through. There are definitely some optimizations that could be made. For instance, we don't need to make a temporary directory here. It was just a convenient way to do it when I was using shell scripts. But now I could very easily just pick a temporary name on the local side, and as part of the remote processing, or when it uploads all the files, it just creates that directory as the first thing it does. So we don't necessarily need to use make temp, but that's how I implemented it right now. This also gave me a good feel for how the SSH client functionality works in Go, which also presented some challenges that I'll mention in a minute. SCP is a little bit of a different animal, so I actually found a library that helped me do that, and did the same sort of thing. We copy this executable that's running, so os.executable will get us the name of the currently running executable, and we can just SCP that up. We copy the config file, and then for every artifact, artifacts do allow globbing, so we have to do basically for each artifact, glob it, and then for each match down here, SCP that up as well. One thing that I did notice a little bit later is that permissions aren't always right, so this might have to get changed a little bit. Definitely when we unpack the tar file on the remote side, but this 0644 might also not be correct as well. Then finally, this is the kind of that last command in the local script from the first part of the video. Basically just run whiskey on the remote side. So it's basically the same command, just with a few things parameterized. And I did need to add getting the status, then cleaning up after ourselves, and then exiting with a particular status code, so that if running whiskey on the remote side hit a failure condition, this overall command would exit with a failure code, and then we could check that down here when the session ended. You'll notice I am using some Go routines here. I think this ended up being necessary because the input, output, and error streams are asynchronous. They're full duplex, so you could be writing stuff in while stuff is coming out, and you kind of want them to come out when they're actually being shuttled back and forth. So that's basically it, and then we close the SSH client. So now on the remote side, down here, run remote. Again, we get the config, and we've SCP'd both this program and the same config that we're using, so we know we're using the exact same version of whiskey and the exact same configuration, so there's no mismatches there. Then, similar to when we SCP'd all the artifacts up, we run through all the artifacts, glob them, all the same logic here, except for each match in the globbing, we're unpacking the file. So right now we just support tar.gz, but in the future we could easily support others. There is actually a library that I tried using. There was an issue that I had. It was pepcac problem exists between chair and keyboard. So I had an issue where I was actually not SCPing tar.gz up. I was SCPing something totally different, and that's why I had trouble unpacking it, because it wasn't actually a tar.gz file. So I can probably make this support many different file types very easily just by using another package. And then this block here is just for debugging. Just list all the files that are present, just to make sure A, all our files got uploaded properly, and B, they all got unpacked the way we expect them to be. So that's why that's in there. And then everything else is pretty much one-to-one correlation with either the section in the original script or one of the utility commands that was kind of built into the process. So we get a new folder name based on the date. We get a new deploy directory, which we then will pass in to the environments of every single shell that we spawn. So we actually spawn, in this case, bash. I've been toying around with the idea of making this configurable in the future, or ideally, I would like to fall back to the current user's default shell on that side. In this case, it's the remote side. So whatever your shell is configured for the user that's currently logged in, when you log in over SSH, if it's bash, use bash. If it's CSH, use CSH, just to avoid any confusion and any weirdness there. So, but for right now, bin bash, we spawn bash, and we run. This is just an array of strings, or I guess it's a slice technically in Go. So in this case, run the copy commands. Down here are the build commands, the post inst commands, and then the restart commands. Now in between, we also have some of the same kind of housekeeping stuff that we did in the shell script. The first thing is actually something that we added. I added the requirement that after the copy step, the path contained in deploy directory has to exist and it has to be a directory. That way, if you want to take a directory that's in the artifacts tar that you send up there, and just copy a full directory to the new deploy directory, you can do that. You don't have to dive into that directory and then copy all of the individual contents and make sure to account for dot files and all that stuff into the deploy directory, and then have the responsibility of creating the deploy directory be on Whiskey's side. So this kind of makes it more flexible, but it does require that we don't really care what you do in the copy commands. We just care that at the end of those commands, the path at deploy directory has to exist and it has to be a directory. And other than that, you can do whatever you want. Okay. And then obviously after the build step, but before the post install step, we have to update the symlink. And I toyed around with a couple different ways of doing this, but it seemed like the easiest would be just to leverage the shell and tell it to update the symlink, rather than deal with the semantics of, does the symlink exist? If so, delete it, recreate it, and deal with all that. So in this case, I just call ln-sfn and then the symlink information, which this is the exact same command that came from the shell script. And then finally, we clean up old deployments. And just like with the updating the symlink, I decided to just go for the strategy of use the same commands. So cd into deploy base and just delete all but the top 5 or the most recent 5 deployments. So exactly the same thing as it's doing in the shell script. And that's basically it. Now I did run into a few challenges while I was doing this, and I have to refer to my notes here. The first thing I ran into was I wasn't using my Mac. This is my Mac that I'm recording on right now. I did use my Windows machine, and Windows Subsystem for Linux for some reason wasn't set up properly for IPv6. So that was fun. It couldn't resolve DNS requests over IPv6. So I just had to add a few IPv6 addresses for DNS servers. And then everything started working, but it took me all of Saturday to get Go and the Go tools installed because of it. And I didn't actually realize that's what was going on until I tried to get some packages later on in the week, maybe a couple days later. So that was probably my biggest slowdown. It was just IPv6 configuration issue. Through that process, I learned that apparently Go is very IPv6 happy, which was new and different. So just be aware that if your IPv6 environment is improperly configured or configured a little bit weird, you might run into some challenges there. if you're interested in exactly what I dealt with, leave a comment below, and I'll be sure to answer you, or maybe I'll just do a video on my troubles with IPv6 and Go at some point in the future. The next challenge I ran into was what I'm calling SSH semantics. What this really means is it should have made sense to me that SSH really all it does is run a command on the other side, and most of the time when we SSH and we don't specify a command, well, I guess all the time when we do that, but most of the time that's what we're doing. We're actually getting a shell. So it's instead of running a command that we specify, it's running your default shell, or bin bash or something like that. So that's just a program. Just like any other program, it has standard in, standard output, standard error. Nothing fancy about that. And all three of those streams are independent. So there's no like request response semantics like with HTTP or anything like that. So I was expecting send a command over, get some output, and it's when the output is done, I get some sort of signal. I don't know why I thought that in hindsight, because that's not how shells work. It's standard input, standard output, standard error. That's all it is. So in my case, I got lucky because I don't really have to wait for the output of specific commands. So for instance, here is really where it matters. I can just dump this whole thing, and really all I care about is that the output comes back. Whatever the output is, I don't care about it. I just care that I get some output back and I can dump it to my standard output. I don't have to wait for this command to exit and then try to do something, try to make some determination based on what happened. No, I can just dump this whole line, basically a mini shell script across the wire, and then take the output. That's all I need to do. The next thing is that concurrency played a larger part than I originally thought. I originally thought that I could do this without using any Go routines whatsoever, which, yeah, maybe that doesn't make it a great situation to use Go. But it turns out that it actually made this stuff a lot easier to use Go routines, to have the reading from the streams and the writing to the stream be completely separate Go routines, and then synchronize them with a wait group, and to do a similar sort of thing. So actually in this run commands function, which is down here somewhere, I do a very similar thing. So I open standard in, standard out, standard error, and then I have a wait group, send stuff to standard in, and then I have a Go routine for standard output, a Go routine for standard error, and then I wait for those to be done. And that's how I synchronize. And it ended up being actually a lot simpler to think through and reason through that way. So I already mentioned that I was using a library, it's called Archiver, that I thought didn't like the tar gz files. So I ended up having to kind of write the same code, basically the same code that they had myself, because I thought that there was some issue there. And it turns out that I was just not uploading a tar gz file. So of course it wasn't going to unarchive properly. And then the last one was that getting the exit and status codes from SSH and shell proved to be a little tricky. So depending on how or if you wait for a shell command to exit, or in the case of SSH, a session, you might get I want to say null reference exception. I've been in C# a lot. I forget what Go calls it. But basically a panic, because it doesn't have the status from the process. So you actually do have to specifically say wait for this command to end, which shouldn't be an issue because you're basically already waiting for it to end by all this stuff up here. And then if you get an exit error, this means that it exited with a non-zero status code. And then you can just print that out. So that ended up being easy once I figured out how that was supposed to work, but it wasn't necessarily the most intuitive thing kind of right out the gate. So that's the basic overview of the software. And I did, as a way of testing it out, aside from just using my example over here. So there is an example in the Git repository. By the way, it is on GitHub. I will leave it linked in the description below, github.com/bpark/whiskey. But I'll leave a link down below as well. So there is an example here, but I did want to use it in an actual project. So I pulled up the same project that I showed in the beginning of the video with the shell scripts, and changed it up, ever so slightly. So this is basically the same as the one command that was at the very bottom of this deploy prod stage or job in the original configuration, but now I'm calling whiskey the executable with a new configuration file. But of course, how do we get whiskey? Well, I published it to my website, and I do want, there is no /whiskey/latest, because I think that's a bad way to do DevOps sustainably and in a way that you can guarantee that it's not going to break for some weird reason at some point in the future. So do specify a version. Right now there's only version 0.1 because it's pretty beta. This was an executable built for Linux x64, and that's the path. So we'll grab it, save it to a file called whiskey, make sure it's executable, because wget does not, and probably for good reason, does not automatically make things that it downloads executable. Then we run it with this configuration file. And what does this configuration file look like? Well, it looks pretty much like this. Should look fairly similar to the shell script that we were looking at the beginning of the video, but here it's all in YAML. So we list out the artifacts, the targets, the deploy base, and I did make kind of a conscious, intentional, opinionated decision that all deploy targets should use the same deploy path. We can debate about that offline if you disagree. If you disagree, leave a comment below and I'll respond. Maybe that'll be a really good discussion. So, and then we have our 4 sets of commands: copy, build, post-inst, and restart. 2 things to notice in the restart command that are changes. There is actually a bug in Whiskey that I discovered when I was making this implementation, using it in this project. It doesn't make things executable when it unpacks the tar file, even if they were marked as executable inside the tar file. So this is something that I actually specifically have to execute down here, so I specifically set it to have the execute bit set. And then finally this down here, we did add the requirement that every single command needs to be successful. If any one of these commands fails, it fails the deployment, which in the case of the CI process that I'm using also fails the integration. So I think this is a good thing. Again, I took in a slightly opinionated approach here, but that means that if the previous command, this mypid equals command, doesn't find a PID for the previously running deployment, we shouldn't try to kill it, because kill-9 with an empty PID or kill-9 with nothing after it does fail. It returns a non-zero exit code, and that's detected as a failure, which ends this whole process. So we have to explicitly check for that. Either it's 0 or kill it. So, 0 length or kill it. And that now it all works. So that's pretty much how everything works. And again, this is all on GitHub, so check it out. I do welcome pull requests, issues, additional documentation. If you want to try this out in your project, please go right ahead. If you want to, just test it and see if there may be other things it could do, or find bugs, absolutely go for it. I do intend this to be for the community. I don't. Yes, I built it because I had this particular problem, but I'm sure it's not unique to me. So if you think you would find it useful, please go ahead and use it and give me your feedback. Let me know in the comments. And be sure to like this video, subscribe to the channel, share this with your friends and colleagues, share this with your DevOps team maybe. And yeah, to support the project, go to GitHub and help it out there. You can also support this channel and me. There are some links down below to my website, to Patreon, to some of the projects that I work on that if they work out for you, you can actually subscribe to them and pay for them. They are, paid products, that sort of thing. And thanks for watching this, and stay safe, stay healthy, and above all, keep coding and keep improving the world. So yeah, thanks for watching.